After the teacher
Madam.
leaves, even we should leave. Okay, beta? Next time, be careful.
Ma'am.
Okay, girls? Yeah. Good morning, all of you.
Good morning, ma'am.
So, I take it that you don't have any problem regarding yesterday's lecture. If you have,
No,
you can
ma'am.
ask me right now. If you have at all, you can ask me now if you have any doubts. Yes?
No,
Okay to
ma'am.
start? Okay. Okay. So, this is what we are supposed to do today. So due to time shortage, I said that we will do it tomorrow. Remember? Now we are going to differentiate metals and non-metals based on physical properties. We have done physical properties so far. Now it's a summary. Okay? The first thing, metals are solid, and we talked about the exceptional cases also, beta. Remember? It's mercury. So mercury is in liquid form, which we use in thermometer, right, beta? Hello?
Yes,
Yes.
ma'am.
Yes?
Yes,
You
ma'am.
understand? You understand, isn't it? Metals are
Yes.
Yes,
solids
ma'am.
except mercury. That means metals are solids. But you have mercury, which is liquid. And non-metals can be any type. They can be solid, they can be liquid, they can be gases as well. Understood this much?
Yes, ma'am.
Second, metals are hard. We know that solid and hard, right? Except sodium, remember? I said you can cut it with a knife. Potassium. If you recall yesterday's lecture, so sodium and potassium are very soft metal. You can cut it with a knife or with a scissor. They're so soft. So these are exceptional cases. Non-metals, which are solid, remember, they are brittle. That means coal. If you take coal and you hammer it, it breaks into pieces. Right, beta?
Yes, ma'am.
Whereas diamond, if you hammer it, it will not break. It is the hardest of all. Is it clear? Yes, beta?
Yes.
So this is what we learned. Metals have metallic luster. Metals generally have the shine, so that's called luster. Whereas non-metals do not have at all, but they are dull in color. They look very dull. Okay, so they don't have any shine. Metals have high melting point and boiling point that we know. Non-metals have low melting points. Next, metals are malleable. What is the meaning of malleable, beta? Can be made into thin sheets. Whereas non-metals are non-malleable. Metals are ductile, can be made into thin wires. Non-metals are not ductile. Metals are good conductors of heat and electricity. Non-metals are bad conductor of heat and electricity. There is one exception case. What is that? Graphite. Remember I told you yesterday? Graphite is a non-metal which is a good conductor of electricity. Metals are sonorous, but when you hit it, it produces sound. And non-metals are not sonorous. Tell me if you have understood or not. Hello? Hello?
Yes, ma'am.
Have you understood this?
Yes, ma'am.
Do you want to ask me any question?
No, ma'am.
Now we come to chemical properties. So physical properties is over. One topic is over. Physical properties. How does it look? What are the properties? Right, beta? Now we come to chemical properties of metals and non-metals. We will see how it reacts with certain elements and what happens. First one that we are going to talk about is reaction with oxygen. How these metals react with oxygen and non-metal react with oxygen. Is it clear?
Yes, ma'am.
Yes,
Read it.
ma'am.
Read. Now be careful. You have
Own
to pay
Fatima,
attention.
can I?
Ma'am, can I read?
Oven
Ma'am, not.
Fatima. All of you will have chance with that. Oven Fatima, when you read, You have to understand what you are
Yes,
reading.
ma'am.
Okay, beta? Don't read for the sake
Okay,
of
ma'am.
reading. Don't read for the sake of reading or for getting a chance. No. Read for
Yeah, ma'am.
understanding. Okay, read for understanding, beta. Now you have to change.
Oh, okay, ma'am. Reaction with oxygen. You are familiar with the phenomenon of rusting of iron. You had learned that in both the processes, oxide formation takes place.
Okay. Now, rusting of iron. What does that mean? Rusting of iron. You must have observed at home. You got almiras. You got old iron rods, maybe. After some time, you find that there's an orange colored powdery formation on the surface. Have you observed that?
Yes, ma'am.
Flakes coming off, flakes coming off.
Yes, ma'am.
Yes, so this is oxide. This is iron oxide. What is it, beta? This is iron
Iron
oxide.
oxide.
Iron
This
oxide.
process, yes. So what we say that there is a rusting. What is happening? There is a rusting of iron, and the process is called as corrosion. What is the process called, beta? Corrosion.
Corrosion.
Understood?
Corrosion.
All of you understood now? So
Yeah,
rusting of iron
ma'am.
is called as corrosion. Okay. So what we got? Reaction with oxygen to form oxides. Is it clear? Is it clear,
Yes,
beta?
ma'am.
Okay.
Yes, ma'am.
Read.
Ma'am,
Let's
can I
check
read?
the
Now let her continue, beta.
Okay, ma'am. Let's first check the nature of rust formed as a result of the reaction between iron, oxygen, and water.
Okay. Always remember this is the powder. You saw this rust? This is the powder. And then they have mixed water in the rust. So this is called as rust suspension. And then if you do the paper, litmus paper test, that is whether it is acidic or basic, that we'll do it later. Don't worry about it right now. But rust form only in the presence of iron, oxygen, and water. What is the meaning of water? Where, do you get water in the atmosphere? Do you have water in the atmosphere, Vita? And how come the iron substances are getting rusted? We're not putting water on the almirah. We're not putting water on the iron stuff. So how come the rust is happening, Vita? Can anyone tell me? Hello? Have you understood my question?
Yes, ma'am.
Have you understood my question, Vita?
When,
Yes, tell
yes,
me.
ma'am.
So,
When
from where do you get the
temperature is
water? Yes, Vita?
cold, the when the temperature is cold, the
Okay.
mm,
Yes, yes. Whatever comes to your mind, say. It may go wrong, no? Does not matter. Let it go wrong. Whatever things come to your mind,
temperature
speak up. Yes, tell
when
me.
the temperature is cold, the water droplets can
You're absolutely right. Where are the water droplets? What is the other name of water droplets, Beta?
water vapor.
Exactly. There you are. You got the answer. Who is it?
Nayani
What's your name?
Mahadesa.
Name of this. You got the answer, Beta. So this water is in the form of water
Vapor.
vapor, which is otherwise known as. Have you heard about this, Beta? What have I written?
Moisture.
Moisture.
Exactly. You got the answer? Yes. Now, see what am I writing? What is it?
Mm,
Humidity.
humidity.
Humidity. So
Humidity.
you got so many new words. Say thank you.
Thank
Thank you,
you.
ma'am.
So for water vapor, you got moisture and you got humidity. So that is present in the atmosphere. What do you say? Everything
Yes,
Yes,
is
ma'am.
ma'am.
simple now. It has become simple now. You
Yes.
understood everything now?
Yes, ma'am.
So the presence of water vapor in the atmosphere, if there is no water vapor, remember, if water vapor is, I remove water vapor from the atmosphere, there will be no rust. You understand? So these three
Yes.
combination makes rust to happen. If I remove water vapor from the atmosphere, rust will not happen. If I remove oxygen from the atmosphere, rust will not happen. You are understanding what I'm saying? These three has to
Yes,
Yes.
be
ma'am.
together. These three, presence of these three has to be together. Then and then only rust will happen. Okay? All of you understood better?
Yes, ma'am.
Let's read.
Mama, continue.
Yes.
No, next. Modesa,
Okay, ma'am.
Yes, ma'am.
read.
Activity 3. Collect
Thank
a
you.
spoonful of
Just a
rust.
moment. Owen Fatima, you did well. Good reading. Okay?
Thank you, ma'am.
Welcome. Yes, Modesa.
Collect a spoonful of rust and dissolve it in a very little amount of water. You will find that rust remains suspended in the water. Shake the suspensions well. Test the solution with red and blue litmus paper. What do you observe? What do you observe? Is the solution acidic or basic?
Okay. So what they said that we will take this rust. What we did? We take this rust, that powder, this one. Okay? This is the powder, that brown powder of iron, and
Yes,
collect in a petri plate. Add water to it to make the suspension. Here is the suspension. Got it? So what we did, beta? We added water to this and we made a suspension. Right, beta? Then you will take a litmus paper. You will take a litmus paper. It could be red, it could be blue litmus paper. And in seventh standard, remember I taught you the acidic and basic condition. Remember? If red litmus turns to blue, it is basic. If the blue litmus turns to red, it is acidic. Remember or not? That litmus
yes,
paper we make, yes or no? Remember? I taught you, and I think it is in 11th or 12th chapter,
yes, ma'am.
acid and basics that we have learned. So, if it is it has to be acidic because it is iron oxide. It is metallic oxide. So, metallic oxides are generally acidic. Now, if I
Yes,
take red litmus paper, it will not change. It will remain red. It will remain red. It will not
yes,
change because it is acidic. But if I take blue litmus, if I take here blue litmus, what will happen? The blue
it
will
will
change to
turn
red.
to red.
That shows that it is acidic. Hope you understood. If I take red, it will not change. But if I take blue, the blue will turn to red, showing that it is
Red.
acidic in nature. Is this clear to
Yes,
all of
ma'am.
you? Is this
Yes,
clear?
ma'am.
Okay, better.
Yes.
Now, see the observation what we find?
Observation. You
The
must
red,
have observed
this is
that the
wrong.
red litmus,
It must turns blue. Yeah. Continue,
the
continue.
red litmus, that the red litmus turns blue. The oxide of magnesium is also basic in nature. In generally, metallic oxides are basic in nature.
Okay. Now, what is shown? That red litmus turns blue. Okay. So it is showing that it is basic in nature. What did I say? Did I say acidic water earlier?
Yes, yes,
Yes. So, okay. So shows that the iron oxide is changing red litmus to blue, showing the basic in nature. Same way, magnesium oxide. Magnesium is white powder. When you burn magnesium ribbon, it develops, or the ash which comes down, it is white color. Where you can make the solution of that, again the same thing, the suspension we can make, and again test it with litmus paper. So what we say, what we see, sorry, that if I take red litmus, it will turn to blue, showing that it is basic in nature. So generally metallic oxides are basic in nature. Is it understandable better?
Yes, ma'am.
Yes.
Ma'am, we had learned red litmus turns into the blue litmus in
Blue
seventh
litmus turns to
standard.
red. Exactly. Now you remember? Now
Yes,
you remember
ma'am.
better? Fine, good. So what we have learned that metallic oxides are basic in nature. What does that mean? That red will turn to
Turn to
blue.
blue.
This is the basic in nature. Is it understandable?
But ma'am,
Yeah, ma'am.
in basic form, the blue will not turn to red.
No, better. It will remain blue. It will remain blue.
Okay,
Actually,
ma'am.
you understand? You understand?
Yes.
Here
Yes,
the
ma'am.
red seem to be red only. So I thought so maybe it is the same. Okay, but actually it is turning blue. Now we will see over here one by one. That was the activity. Now we are going to do the theoretical part. Chemical
Chemical
properties of metals and non-metals.
non-metals.
Now first we will start
Ma'am,
with
can
oxygen.
I?
Oven Fatima, let others take the chance better.
Okay, ma'am.
Yes, who wants to read?
Ma'am, can I?
Ma'am, can I?
Yeah, who is it? Give me a
Surya.
name.
Ma'am.
But you have to read properly, remember. Okay, because if you falter, then no one will understand. So I want, because this is a difficult portion of this chapter, so I need someone who will really explain it nicely.
Ma'am, can I?
What's your name?
Ma'am, can I?
Pizza.
Huh?
Nayani Mahadesa.
Pizza
You just read
Fatima.
it. You just read Noyan and Modisa.
Pizza, can I read?
What's your name?
Pizza.
Fizza. Okay, Fizza, start.
Reaction with oxygen. Metals react with oxygen to form a metallic oxide. These oxides are basic oxides because they react with water to form bases.
So how you will
Example,
remember better? Basic oxides. What is the meaning of basic oxides? What you will say? Red,
Red
blue.
turns into blue.
You understand? This is how you have to remember. Okay? Next.
Okay, ma'am.
example, magnesium burns in air to form magnesium oxide. Magnesium reacts with water to form magnesium hydroxide.
Hydroxide. Okay.
Hydro-
Now first see this equations. Magnesium plus oxygen. What we get? Magnesium oxide. What we get, beta?
Magnesium oxide.
Understood?
Magnesium oxide.
Yes. Then this magnesium oxide, it reacts with water, we get magnesium hydroxide. Is it clear? Now how to balance it? I'm showing you how to balance it. Magnesium is 1. Magnesium is 2 over here. Oxygen is 2. Right, beta?
Yes.
Hello? Magnesium is 2 over here. Oxygen is also 2 over here. Okay?
Yes, ma'am. Yes, ma'am.
So this is balanced. Oxygen is balanced 2 over here. Magnesium is 2. But here is magnesium 2. This is how you balance it. If I take it this way, magnesium plus oxygen, we get MgO. Right, beta? How much is oxygen?
Yes.
2. I cannot put 2 over here, so I will put 2 over here, right? Now magnesium has become 2. Magnesium is 1. So what will I do? I'll put 2 over here to balance. Understood?
Yeah.
Understood, beta?
Yes, ma'am.
Now here magnesium is 1. Magnesium is 1. Oxygen is 1 plus 1, 2. Oxygen is 2. Right, beta? Hydrogen is 2. Hydrogen is also 2 outside the bracket. This is how it's called balancing. Are you understanding what I'm trying to show?
Yes, ma'am.
Yes, ma'am.
Now let's talk about nonmetals.
Nonmetals react with oxygen to form nonmetallic oxides. These oxides are acidic oxides because they react with water to form acids. Example, sulfur burns in air to form sulfur dioxide. Sulfur dioxide reacts with water to form sulfurous acid.
Let's talk about nonmetals. They are also forming non-metallic oxides, but here these non-metallic oxides are acids. What are they, beta?
Acids.
Understood the difference? Metallic oxides were basic, non-metallic oxides are acidic. This is clear?
Yes.
Now let's take sulfur. It's a powder form. Now sulfur plus oxygen. What do you get? Sulfur dioxide. Right, beta?
Yes.
And this sulfur dioxide, when reacts with water, it forms sulfurous acid. Now here, S is 1, S is 1. Oxygen is 2, oxygen is 2. It is balanced? Yes, beta?
Yes, ma'am.
Yes. Now let's take this one.
Yes,
Sulfur
ma'am.
is 1. Sulfur is 1. Sulfur is 1. Right, beta? How many oxygen? 2 plus 1. 3. How many oxygen? 3. Is it clear?
3.
Is it clear or not? So sulfur is done, oxygen is done. Now what is remaining? Hydrogen 2. Hydrogen 2. Is it clear? It is balanced.
Yes, ma'am.
This is your understanding. See, I will not say that you will learn. It's not possible. It will take practice. I'm just trying to show you how to balance the equation. Are you understanding or not?
Yes, ma'am.
Yes, that's it. We'll practice and it will become easy. So what did you understand over here? Reaction with oxygen. Metallic oxide is basic and non-metallic oxide is acidic. Is it clear?
Yes.
What is basic? Which litmus turns into which litmus color?
Red litmus turns into blue litmus.
That is basic. And what is acidic, Vita?
Blue litmus turns into the
Red.
red litmus.
Red. Exactly. All of you understood?
Yes, ma'am.
Yes.
Now, do you want to ask me any question regarding reaction with oxygen?
No, ma'am.
No, ma'am.
Yes.
Ma'am, can
Yes,
I read?
ma'am.
Yeah, read Vita. Shalatia.
Take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap on any bottle of wrap of metallic wire around it.
So now we will be working with the sulfur powder.
Okay.
Take in a deflagrating spoon and we will heat it. If you don't have the spoon, we can take any metallic cap. Okay? Let's see what happens.
Yes, ma'am.
Ma'am,
Next
yes,
person.
ma'am.
Ma'am,
Yes,
can I
Vita,
read?
I need name, Vita.
Misbah.
Nayani Mahadisa
Misbah. Okay, Misbah.
Right,
Misbah read.
from left.
As soon as sulfur starts burning, introduce the spoon into a gas jar or a glass tumbler. Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus papers.
Okay. Now, when you're heating the sulfur, it starts burning. When it starts burning, you have to put this spoon with the sulfur into a gas jar and cover it with a lid so the gas is not escaped. After some time, remove the spoon and put little bit of water into the tumbler and again close the lid. Shake the tumbler and what you will do, you will again take the blue litmus paper or the red litmus paper. I want to show you how does it look like. This is the deflagrating spoon. Can you see this?
Yes.
And this is kept in the, so this is how the spoon looks like. And the spoon is kept in the jar. You can see this bell jar like this and
Yes.
this is the
Yes,
lid.
ma'am.
This is the lid. And after some time, when you put the water in it, you're removing the solution outside and we check it with the red litmus paper. Yes.
Can I read, ma'am? One Fatima.
Ma'am, can I read?
Yes, oven Fatima.
Okay, ma'am. The name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid, acid is formed. The reaction can be given as follows. Sulfur oxide
Plus water.
plus water, sulfurous
Sulfurous
acid. The sulfurous acid turns blue litmus paper red. Generally, oxides of nonmetals are acidic in nature.
So whatever we did theoretically, remember here we did. Take you back this one. Got it now? Sulfurous acid. Understood? The same thing we are showing. Hope you understood now. This is theoretically, we are showing practically. Have you understood, all of you?
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yeah. This was theoretically, and what I'm showing you right now is this is practical. Okay. So what we observed, the sulfur when is burnt in the presence of oxygen, we get sulfur dioxide. What we get, better?
Sulfur
Sulfur
Sulfur.
dioxide.
dioxide. This we got. Okay. Now we added water in the bell jar. So when we add water in the bell jar, this sulfur dioxide is mixing with water. Agree?
Yes, ma'am.
So when it got mixed with water, what we got? Sulfurous acid. What we got, better? Sulfurous acid. Now this sulfurous acid we have to test whether it is acidic or basic. And what we found that it is acidic in nature. That means the blue litmus is turning red. Any problem?
No, ma'am.
All of you? Now, earlier, along with Owen Fatiman, who said who wanted to read Beta? What's your name?
Ma'am, I'm Nayani Mahdisa.
No, nobody said. Okay. Now you will read. Okay. All of you understood this much?
Yes, ma'am.
So now reaction with oxygen is over. Do you want to ask me any question regarding reaction with oxygen, with
No, ma'am.
metals
No,
and
ma'am.
non-metals? Is it clear? All of you? Any
Yes.
confusion?
No, ma'am.
No, ma'am.
No, ma'am.
Now we are going to do with reaction with water. Okay, metals and non-metals. Now the things are becoming easy for you.
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay. Now we will see how metals and non-metals react with water. Please read.
Note: sodium metal is very reactive. It reacts
Vigorously. Vigorously.
vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene.
Now let's start with sodium metal. It's very reactive. As soon as it comes in contact with air, that means oxygen and water, lot of heat is generated as if it will explode. You understand? And it explodes. That means it just comes out of the vessel. Hence, it is not stored in water or not, neither it is stored empty. It is stored in kerosene. Where it is stored, better? It is stored in kerosene because
Yes.
in kerosene it does not react. Did you understand?
Yes, ma'am.
Yes, ma'am.
So if I ask you why sodium metal is stored in kerosene, what you will say? Because if it is kept empty, then it comes in contact with the water vapor present in the air and the oxygen, and it can be explosive. It will like a small bomb. You understand? So as not to happen, we
Yes,
get keep
ma'am.
it in the kerosene. Read.
Activity 5. To be demonstrated by the teacher. During demonstration, special care should be taken that the size of the sodium metal piece is roughly the size of wheat grain. It should be held with a pair of tongs. During observation, kept away from the beaker.
Understood? You are
Yes,
not supposed to do this sort of experiment only in presence of teacher, or only the teacher should do it. Why? First of all, you can see the size of the wheat grain, how small you should take. Then also it will explode if you don't take care. So you cannot touch it like that. You have to take the help of a tong. Tong, it's like a fork type of thing.
yes,
It's like a, what do you call that? With which you hold something that is called a tong. And you have to keep it in such a way that it is away from you. You have to hold it in such a way that it is away from you. Otherwise, you may be hurt. Yes.
Activity 5. Take a 250 milliliter beaker glass tumbler. Fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in the cotton into the beaker. Observe carefully.
Now you will take a small beaker or a glass tumbler and half the tumbler you fill with water. Take sodium metal, take a small piece of that sodium metal, you can cut it with scissor, I told you already. Then you dry it with filter paper and take a cotton and you put that small piece of sodium inside the cotton. Take this cotton in which there is a sodium piece into the beaker and what you see. Can you see this? Can you see this, Vita? This is what
Yes, ma'am.
happens. It is on fire. Can you see
Yes,
this?
ma'am.
This is what
Yes,
happens.
ma'am.
So this is reaction, okay? This is reaction happening. Now what happens next? Yes, read Vita.
Ma'am, can I read?
Read Vita.
When reaction stops touch the beaker, what do you feel? Has the beaker become hot? Test the solution with red and blue litmus paper. Is the solution acidic or basic?
Okay. Now reaction will stop after some time. Obviously, it cannot keep on reacting. It has to stop, isn't it? So all the sodium metal will be consumed. Okay. After the reaction gets over, you touch the beaker. What do you feel, Vita? I just showed you. What will you feel when you touch the beaker?
Hot.
Simple, it will be hot. Now you take this solution and test it with blue litmus paper or the red litmus paper and see what happens. Yes, read it.
Can
Next.
I?
Okay.
Can I?
Who
And
said the
can I?
next?
And
Next is
Nayani
Ma'am,
Mohta.
can I?
Misbah. Ma'am
Naina
can.
Modesa. You just read it, no?
Select. Owen
Ma'am,
Fatima. Misbah.
ma'am, I had not read.
Which one? What's your name?
Nayani Mohta. Just now the someone else read it.
Someone else read it? Okay. Fine. Naina Modesa.
Yes, ma'am. You
Read
observed
properly,
that sodium reacts. Uh,
vigorously.
you observed that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water slowly. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a very reactive non-metal. It catches fire if exposed to air to prevent the contact of pho-
Phosphorus. Phosphorus.
phosphorus phosphorus with atmospheric oxygen. It is stored in water.
Okay. What you observe here, the sodium is reacting very vigorously, very violently in water, right, beta? That it catches fire, isn't it? Sodium caught fire in water. What do you say?
Yes, ma'am.
Hello? And other metals, they don't react so violently with water. For example, let's take the example of iron. It reacts with water, no doubt, but it is reacting very slowly, right, beta? So these are metals. We talked
Yes,
about sodium metals, we talked about iron metal. Now let's talk about non-metals. They do not react. They do not react with water. Non-metals do not react with water. Remember, some non-metals, they react in air. So these non-metals, they are stored in water. Now phosphorus, if we take the example, is very reactive. Remember that. If it is exposed to air, it will catch fire. So what we do? What we do? It is stored in water.
we
Is it
stored in water.
understandable? Yeah, because it
Yes,
catches fire in air. Sodium catches fire in water. So what do we do? We store in kerosene. Are you understanding what are we doing?
yes, ma'am.
Phosphorus catches fire in air. So it should not happen that way. So we store it in water. So it will not come in contact with air. Is it clear?
Yes, ma'am.
Now we will do it chemically. Reaction with water.
Re- Reaction with water. Metals react with water to form metal hydroxide and hydrogen. Example: sodium reacts with water to form sodium hydroxide and hydrogen. 2Na plus 2H2O,
Leave that.
2
You leave that.
and
You leave that. You read magnesium reacts with water.
magnesium reacts with water to form magnesium hydroxide and hydrogen. Non-metals do not react with water.
Good. Now let's take up sodium. It's just a revision part that we are doing. Sodium reacts with water, we get sodium hydroxide and hydrogen, right? Same way. Magnesium reacts with water, we get magnesium hydroxide plus water. Sorry, hydrogen. Is it clear?
Yes, ma'am.
So these are the metals reacting with water. So what exactly we are getting?
Mm,
Hydroxide. What are we getting?
hydro.
Hydroxide and hydrogen. Is it clear?
Yes,
Yes,
ma'am.
It's clear? Okay. Same
yes,
way, sodium is 2, right? Sodium is 2, isn't it?
Yes.
Hello,
yes,
oxygen is 2, oxygen is 2, hydrogen is 4, 2 twos are 4. So you can see 2 twos are 4, hydrogen, 1, 2 hydrogen
yes,
over here, and this is again 2 hydrogen. So 2 plus 2, 4.
four,
This is how we have balanced it. In the other case, magnesium is 1, magnesium is 1. Hydrogen is 2, hydrogen is,
two.
here is 2, right? It is not balanced. It is not balanced. So what we will do? It is not balanced beta. So what we will do? Hydrogen is
Mm,
2 and 2, 4. So to make 4,
two,
we will
four,
put 2 over here. So it becomes 4, hydrogen is 4. Oxygen is
four.
2, oxygen is 2. Right beta? Magnesium is
Yes.
1, magnesium is 1.
Ma'am,
So this is how it is balanced. Is it understandable?
Yes, ma'am.
So
yes,
metals
ma'am.
react with water, but non-metals do not react with water.
Water.
Okay? I think this is what we
Yes.
will keep it.
Yes,
Yes. These are reaction with acids. No, is there 1 minute left? Okay, read it.
Ma'am, can I?
Precautions to be taken. Warming. Keep the mouth of the test tube away from your face. Use test tube holder to hold the test tube.
Thank you. That means you are taking the acids, reaction with acids, isn't it? We did reaction with oxygen. We did
Yes.
reaction with